Hello students and welcome to my channel Maths Hub. So in this video, we will talk about the linear dependence and independence of vectors. So let's see what is the concept of linear dependence and independent. So vector matrices x1, x2, xn, they are said to be dependent if all the vectors, that is, vectors generally represent a row or a column matrix, right? So they are of the same order. N scalars lambda 1, lambda 2, lambda n, not all 0 exist such that lambda 1 x1 plus lambda 2 x2 plus so on up till lambda n xn equal to 0. So that means any set of vectors, they are said to be dependent. First of all these vectors should have the same order, right? And when we express them as a linear combination, so if the values of these lambda i's are all not zero, then we say that they are linearly dependent. And in case we get all the lambda i's equal to zero, then it is a case of linear independence, right? So that means whenever the lambda i's are all not zero, so this is important, they are not all zero, then it is linearly dependent, otherwise they are linearly independent. So we can also define the linear dependence and independence according to the rank method. So we have seen in my previous videos how to calculate the rank of a matrix. So if the rank of the matrix of the given vectors is equal to the number of vectors, then the vectors are linearly independent, right? Suppose we are given some column vectors and we are given three set of column vectors. So when we stack those column vectors in the form of matrices, so suppose these are the three column vectors and I put them in this form. So I'll get, suppose, a 3 cross 3 matrix. So now it is representing a matrix, and when I calculate the rank of this matrix, if the rank of this matrix, that means we had three column vectors, so if the rank of the matrix comes equal to 3, then we say that it is linearly independent, right? And if the rank is less than the number of vectors, then we say they are linearly dependent, right? Now we can also relate them with the system of equations. I'll tell you in the questions itself that how the rank, when it is equal to the number of vectors, it is representing a linearly independent system, right? So let us take up the first question. The first question says that examine the following vectors for linear dependence and find the relationship if it exists, right? So if you see that these vectors are in the form, they are of the same order, right? So there are three coordinates in every vector. Secondly, we have to make a linear combination. So it is lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 plus lambda 4 x4 is equal to 0, right? So now we will represent these vectors in the form of a column matrix. So we write lambda 1, the column matrix becomes 1, 2, 4. Then we have the second one as lambda 2, x2 is 2 minus 1, 3. Then we have lambda 3 and the vector becomes 0, 1, 2. Similarly, the last vector lambda 4 and the vector is minus 3, 7 and 2, right? And we equate it to 0. So now when we frame the equations, which equations we will obtain? We'll obtain the equation. The first equation that we'll obtain is lambda 1 plus 2 times lambda 2 plus 0 lambda 3 minus 3 lambda 4 is equal to 0, right? Similarly, the second equation obtained is 2 lambda 1 minus lambda 2 plus lambda 3 plus 7 times lambda 4 is equal to 0. Likewise, the third equation obtained is 4 lambda 1 plus 3 lambda 2 plus 2 lambda 3 plus 2 lambda 4 is equal to 0, right? Now, if we proceed by rank method, or maybe we reduce it to a row echelon form to get the values of lambda i's, let's represent it. So they are representing a homogeneous system of equations, right? So now when I represent it in the form of a matrix, we get 1, 2, 0, minus 3, then 2 minus 1, 1, 7, 4, 3, 2, 2, and we multiplied with the unknowns, that is lambda 1, lambda 2, lambda 3, lambda 4, and we put it equal to the right hand side vector, that is a 0 matrix, right? Now when we apply the row transformations, So after applying the row transformation, R2 is R2 minus 2R1 and R3 is R3 minus 4R1, we get this reduced matrix, right? Further, we can do one more operation. We can make this also 0 by subtracting R3 and R2. So when we do that, we get the matrix similar to this matrix, right? And now when we frame back the equations, we will get the equations to be lambda 1 plus 2 lambda 2 minus 3 lambda 4 is equal to 0, minus 5 lambda 2 plus lambda 3 plus 13 lambda 4 is equal to 0, and lambda 3 plus lambda 4 is equal to 0, right? So now from here we can assume one of the variables, the one of the lambda is to be a variable. So let lambda 4 be equal to t. So from here lambda 3 comes out to be minus t. When we substitute in the second last equation, we get lambda 2 as 12t by 5. And similarly, when we substitute all the values in the first equation, we get lambda 1 as minus 9t by 5, right? So all the vectors are coming in terms of t. And what was t? T was lambda 4. That means every vector, every value of lambda I, it is not equal to 0. It is coming out to be some non-zero value. Hence, the given vectors are linearly dependent. Now, how to get the relationship between them, how to get the linear dependence, right? So we had seen that we had taken up the relation lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 plus lambda 4 x4 is equal to 0, right? So let us put in the values of lambda i's. Lambda 1 is minus 9 by 5 t x1. Then we have lambda 2 as 12 by 5 t lambda x2, sorry. Lambda 3 is minus t x3, and lambda 4 is t times x4 equal to 0. So now we can divide the entire equation, or we can multiply the entire equation by 5 minus 5, and then we can divide by t also, right? So we will finally get 9x1 minus 12x2 plus 5x3 minus 5x4 is equal to 0. So this becomes my relationship, the linear dependence of the vectors, right? So this is how we calculate the questions on linear dependence and independence, right? So in case if by solving these equations we get all the values of lambda is equal to 0, then it will become a case of linear independence, right? So now let us move on to the next question. So you need to check, is the vector system x1, x2, x3 given, they are linearly dependent or not, right? So the first job is to convert these equations as lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 is equal to 0. So from here we get lambda 1, 2, 2, 1 plus lambda 2, we have 1, 3, 1, then we have lambda 3, we have 1, 2, 2, and this is equal to 0. So now when we frame the equations, we get 2 lambda 1 plus lambda 2 plus lambda 3 is equal to 0. Similarly, the second equation is 2 lambda 1 plus 3 lambda 2 plus 2 lambda 3 is equal to 0. And the third equation is lambda 1 plus lambda 2 plus 2 lambda 3 is equal to 0. So when we frame the equations in the matrix form, we get 2, 1, 1, 2, 3, 2, 1, 1, 2. Now, as according to the definition of rank, now we have stacked all the vectors, so there are 3 column vectors now. So if on reducing with the help of elementary row transformations, we get the rank of this matrix equal to 3, then it will be linearly independent, right? So we first interchange row 1 and row 3, we get this matrix. And after interchanging this, we can apply the row transformation. R2 is R2 minus 2R1 and R3 is R3 minus 2R1. So we get back this matrix. And finally, we can add these two rows. You can clearly see that this element will become 0. And on doing that, we get finally 1, 1, 2, 0, 1, minus 2, 0, 0, minus 5. So in this case, you can say that the rank of this given matrix, if I denote the matrix with A, the rank of this given matrix is 3, which is same as the number of vectors given to you. So what will happen? The vectors are linearly independent, right? So I hope the question is clear. So this shows, so you can also solve, otherwise you can also uh, give a judgment about your solution with the help of rank, right? Okay, so now you can practice all these questions, right? I've given you 6 questions to practice. And if you have any problems, do let me know in the comment section. And those of you who have liked the video, just hit the like button. And those of you who have not subscribed my channel, do subscribe my channel to get the latest updated video. And do share the videos with the ones who want them. And believe in yourself and you will definitely succeed. Thank you so much.